Okay, first step is to write down. Whoops, there we go. First step is to write down maybe. Hmm. Should I do free body diagram? I'm going to do a free body diagram for the joints first, and then I'm going to write down a list. So yeah. So here's my free body diagram. I know that the reaction force at A, since that's just a roller support, it's just one reaction force, and then a reaction force at C, and in the Y direction and in the X direction. So there's two there because it's a pin support. And immediately, well, wait, I missed one. Right, there's a force there. Okay, now I'll draw my list. Write my list. I'll write it. I'll write the list. So there's my list. I know that I have those 3 reaction forces plus 7 forces within the members because there are 7 members. And now I'm going to start solving for the reaction forces. So I shall pick a pivot point, which usually I'll just start with A. Pivot on A. Pivot A. Pivot A. Pivot A. Pivot? No, pivot. Pivot A. What? Yes. So pick A as the pivot point. That mean, maybe we should look over here. That mean, well, the moment due to the force at B, that's a negative moment, huh? The moment from B is negative, and we have this negative, and that's actually, maybe I need this, I think. Well, we can calculate that moment. That's a 5 times 200, huh? It's a 5 times 200. Remember, it's the moment. The moment equals the force times the distance. So it's a perpendicular distance. It's a 5 feet there. It's the 5 feet there. And we have this is a 5 times 200, which is 1,000. Is it? No. Yes, it is. Yeah, it is. 1,000. I'm good at math. No, I'm not. 5. What am I doing? 5 times 200. That's 1,000. A moment of 1,000 foot-pounds per pound. Yeah, foot-pounds in the negative direction. And then I have the moment due to the force at D. That's a positive moment. So moment is due to D. Be quiet, cat. Moment due to the force at D is a positive moment. And we have, well, that distance is 6 feet. 6 times 100. 6 times 100. What is that? That's 1,000. No, it's not. It's 600. So which one's winning out? Definitely the moment due to the force at B. So this one's winning. So it's spinning this way. Unless C has anything to say about it, and C then has to point upwards. Right? So I said quiet. So C's pointing upwards so it can counteract that moment. So can you quiet, please? I'm trying to. All right. So the moment due to the force at C, that's gonna be positive. So we put a 600 plus the MC. Well, that's the force. We don't know the force, so we can just say RCY times the distance. What is the distance? The distance is that one. It's 12 feet. And that equals to 1,000. Subtract 600, and I get RCY times 12 equals 400. Divide by 12. And then I get RCY. RCY, well, that is 33.3 repeating pounds of force. And that's a positive direction. We already decided that RCY is 33.3 LB positive direction. Okay, that's pretty good. That's very nice. That's very nice. So that's pivoting at A. Ooh, I noticed something. Look at this. The external forces in the X direction are there and nowhere else. All the other forces are within the members. So, what's that mean? I'm at the D. That means that this one is 100 pounds in this direction. Has to balance it out. So I'm going to put an arrow there, and I'm going to say that's 100 pounds. 100 pounds right there. So then that's RCX, 100 pounds. 100 pounds of force, and that's in the positive x direction. So there we go. That's nice. And then what else do we have? Well, I can pivot around the other one. So I pivot around the other support, pivot around the C, pivot around the C, pivot, 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 pivot around the C, and then I take a look at the moments. Huh? So I pivot there. This moment due to the force at B make a positive moment. So that's nice. So the moment due to the force at B is a positive. What is that moment? That is 200 times the perpendicular distance. 200 times 7, that's 1,000. No, it's not 1,000. 200 times 7, that's a 1,400. I think so. And in the moment, well, if this is pivot, the moment, oh, this is also positive, no? Yeah, this one want to make it go positive. So what is the perpendicular distance? It's not like this distance, no. It's not this distance, because that's parallel. It's this distance, which is 6 feet. So we have 100 times 6. What is that? You got it, 1,000. No, it's 600. Settle down. And that's 100 times 6. 100. That's a moment due to the force at D. This is getting good. These are also positive. So that is, what do we say? I do not remember. 100 times that. 600. 100 times the 6. Because that's just the moment. It is using the force times the distance. That's a 600. So, that means, how does this work? Well, these moments are adding together, right? And they want you to spin this way. So that means the force at A has to be going upwards, so you can counteract it. So we have this. We can put that there, and that would make it a negative moment. A negative moment due to the force at A is a negative. So what do we have? We have 1,400 plus 600. What is that? 1,000. No, it's 2,000 this time. Why am I talking like that? I don't know, but it's fun. R-A-Y times the distance, right? Times the distance. Here's a distance here. And that's a 12. That's a 12, you know? That's a 12. And then it's a 2,000 and we divide it by 12. We simply divide it by 12. And when we divide it by 12, we get our answer for R-A-Y. So R-A-Y, what is that equal? Well, that's a 166.6 repeating forever. Forever it repeats. Pounds. And we decided it's a positive, no? Yes, it's a positive direction. So it's a positive. We have R-A-Y 166.6 pounds of force in the positive direction. We got all the reaction forces. We are done with that. That's very nice. Okay. What do we do now? Well, I think we shall look at the other forces, the forces in the members. Oh, look at this. Lordy, lordy, lordy. This is easy. Joint A, look at that. Look at that. I'll put a box around there. Yes. I take this, take a look at joint A. I still have to look at the joints now, huh? So I look at the joint A. I write the joint A down. I look at like this, and I have a A. There's A. I have the reaction force at A. That's we just decided RAY. That's 166.6 pounds of force. That's a positive, and we have some kind of force this way, some kind of force